In this screencast, we are going to talk about the geometric mean and the two different equations that go along with it. We use the geometric mean when we're dealing with percentages, which also can include ratios and index and rates, things like that. So when you have those kinds of numbers, you're going to use a different formula than just taking the mere average like we've done in the past. And this is very useful. We see it done with stocks and bonds, and you use it in a variety of different places, growth of companies. So it's a very applicable calculation. So the first way to do the geometric mean, and you'll notice that we're using GM as kind of our definition there on the side. We're going to take it to the nth root, and we'll talk about the nth root when we get to an example. And then we take each of the rates. So actually it's easier if we read the example down below. So for instance, the return on investment earned by Atkins Construction Company for 4 successive years was 30%, 20%, negative 40%, and 200%. What is the geometric mean rate of return on investment? So we're going to look at those each individually. So if you go down to the bottom of the screen here, we see first of all that we're going to take this to the nth root, the number 4 there. And the reason we're using the number 4 is because we have 4 numbers basically that we're using, or over 4 years. So we have the 30%, 20%, negative 40, and 200%. Now you have to turn these numbers. You can't just put 0.3. We have to show that there was an increase of 30%. We went up 30%. And so you'll notice down here in our equation, that's why we have 1.3. The 1 signifies that we got up to 100%, and then we continued going up another 30%. And so that's where the 0.3 comes from. So then with the 20%, we were once again at 100%, so we have 1, and up 20%, so we have the 0.2. Now in the next case, we have a negative 40%, which means we didn't get to 1. And so we actually take 1 minus that 40%. So we take 1 minus 0.4, and we end up with 60%. That was what was left. We only got to 60%. We didn't get to 100%. And then when we have a 200% investment, we go up to that 1, and then we go up 2 more times. And so that's how we got the 3. We got to 100%, and then we went up 200%. So you go up 2 more places. So that's where all of those numbers came from. Okay, so we're going to take this to the 4th root and then multiply our percentages together. And so that's how we get an increase of 29.4% on average over those 4 years. Okay, you see that there? So 1 signified 100%, and then we kept going up 29.4%. So this is the first kind of geometric mean, and it's when it's given us rates over several years, but we have a rate for every year. Now sometimes in this next example, we see that we have a start and an ending period. So in this example down here, during the decades of the 1990s and into the 2000s, Las Vegas, Nevada was the fastest growing city in the United States. So the population increased from 258,295 in 1990 to 584,539 in 2011. This is an increase of 326,244 people, or 126.3% increase over that period. So what was the average over that period? And in other words, every year, about how much did it grow? And so this is a pretty straightforward equation. We're going to have the value that was at the beginning of the period in the denominator. So we started with a population of 258,295. Okay, and then we ended at the 584,539. So that goes in the numerator. Now we take the nth root of this, and 21 is actually 2011 minus 1990. So it was the difference in years. So similar to the last one, except this time we're accounting for every single year that we were accumulating over that time period. So we take this to the 21th root, and then we subtract the 1. Now, in my opinion, it's really strange. In the first equation, we don't subtract the 1, and in the second equation, we do subtract the 1. But that's just how this equation goes. So you could read this number right here the same as we did last time with an increase of 3.97%. Or you can subtract that 1 and once again read it as an increase of 3.97%. So that's an increase of about 4% per year, so over the course of that 21-year span. So let's go ahead and jump into Excel and just see how we might be able to do this. So here's an example. Listed below is the percent increase in sales for the MG Corporation over the last 5 years. Determine the geometric mean percent increase in sales over this period. Okay, so in each of these we have an increase of 9.4%, 13.8%, and so on. And we're trying to figure out what the geometric mean is. So over here in Excel, we can see our, oh, there's only 4 points there. What am I missing? 14, 11, oh, 11.7 and 11.9. I missed the 11.9. Okay, so here are our 5 different percents. Now, one thing I need to do is I need to turn this into the form like we had before. So if I go back to this example over here, remember we turned these and put the ones in front and made them true percentages showing the increase or the decrease. So over here, instead of 9.4, the number I'm going to use is 1 point, and then we had an increase of 9.4%. Okay, so we went up to 1, and then we went up another 9.4. So that's where the 1.094 came from. In the next one, we would have 1.138, and then we'd have 1.117, 1.147, and 1.119. Now, in none of these cases did we have a decrease. Remember, if we had a decrease, we'd take 1 minus that number. Okay, now we're going to go ahead and multiply each of these. So I'm going to take this one times this one times the next one times the next one times the next one. Okay, so we're going to multiply all of those. Now, what we needed to do in our equation was take the nth root of that. And another way to do that is to turn it into a fraction with a power. So we're actually going to take this to the 1 over n, and n in this case was 5 because we had 5 data points. So I'm going to take this to the 1 over 5. So algebraically, it allows us to do that, and that's easier to put into Excel. So we took this to the, how do you say that, 5th square root, or the square root to the 5. So we have our 5 numbers, we multiplied, and we're going to take it to the 1 over 5. Remember that 5 number just comes from the point that we have 5 data points, and that's always how this geometric mean will be. So when we hit enter, we see we get 1.1228. So this would be an increase of, if we move that decimal point over, 12.28% on average. So that's the geometric mean with the rates. Now, in our next question down here, let's move back to our question slide. In 1996, a total of 14,968,000 taxpayers in the United States filed their taxes electronically, and by 2010, the number increased to 99 billion. So what's the geometric mean annual increase over this time period? So first of all, let's go ahead and figure out what is our time period difference. So I'm going to take 2010 divided by subtract 1996. Okay, so we have 14 years that we're dealing with. Now, so that's going to be our nth root, is going to be 14. So now we're going to put in the numerator is our ending year, and in the denominator is our beginning year. So in my numerator, I'm actually going to have the 99 billion, that was what we ended with, and I'm going to divide by what we started with, which was the almost 15 billion. And then at that point, like I did up above, I'm going to take it to the 1 divided by 14 because we had 14 years and we're taking it to that 14th root. So when I hit enter, I get 1.1447. So if I subtract that 1, then I end up with 14.45-ish% increase per year. And so that's how you find the geometric mean when we're dealing with a start and stop over a year time period. And that finishes this screencast.